Hello there, my name is Lukram and welcome to this short video about fuel logic. Let's hope it stays short, but basically I'm gonna show you guys a simple way of doing fuel logic and a more advanced way of doing fuel logic. So, to keep this short, let's head straight into it, shall we? Alright, so don't worry about this, I know it kinda looks complicated, but I'm gonna break it down and it's gonna be quite simple. Now, technically, the only thing you really need is the light blue part. This is the main core of the logic circuit, and it's gonna do the heavy lifting and pretty much everything. It consists of an accumulator that's gonna be controlling how much fuel we have. Right now it's 100%. When it fills completely, it's gonna be 0% fuel. And we have these two comparators that are just checking if the accumulator is full, and if it is full, they're gonna turn off these XOR gates. We can demonstrate this by pressing space. If I press space, the thruster just goes off. If I press W, the engine starts spinning the wheel. And you can already see that fuel is getting used up. And this section over here is what's gonna be controlling the fuel consumption and addition. The two things over top, first we have an arithmetics block and an OR gate. This one is for the engine, and then the red one is for the thruster. The red one is consuming twice as much fuel as the engine because I set it up that way, and the last one at the bottom here is just a way to add fuel back in, which is quite simple. It's just doing the same as the other ones but in reverse. So instead of a positive input, you give it a negative input. Alright, if we go and consume the whole thing, if we use those things, it's gonna consume it faster, but now it is over and you can see I'm pressing the space indicated by the light up there, pressing W or S, and they won't work because the fuel is consumed. Yeah, we can just refuel our tank, and now we can go back up. Keep in mind that I set this up to have very low fuel capacity just for the video, but you can customize it to have pretty much as much fuel as you want. So let's head up into build mode, shall we? Now that we are here in build mode, I can show you more properly how these things are connected. So we're gonna start with the accumulator. We're gonna have it set to a minimum of 0 and a maximum of 100. And then the scale is just gonna determine how fast or how slow the fuel gets used up. So right now I have the scale set at 10. It means that it will take 1 second to move 10 values. So if I hold it down for 1 second, it's gonna move up to 10. For 2 seconds, it's gonna move up to 20, and so on and so forth. So it's gonna take a total of 10 seconds to consume all the fuel. Now this is connected to both comparison gates. Both are set up the same way. Just threshold 100 because that's the maximum we set up. We set it to equals, and then we output 1, and those go into XOR gates. We need 2 of them because an XOR gate will give an output exclusively if there is only one input active. So by giving it 2 inputs, we're forcing it to stay off no matter what. Now in the XOR gates, quite simple, just we have the controls for the things inside the XOR gate, and that goes to the thing. So XOR gate with space goes to the thruster, XOR gate with WNS goes to the engine. And I have it set to 0.05 just so it doesn't spin forever. If you want to add more things, it's just as simple as just adding another XOR gate and connecting these things here. And now you can have another thing that gets disconnected once the fuel is all used up. Over on this side, which is also quite simple, we're going to control how much fuel gets used up. So first we have here the arithmetics block. This OR gate right here is just so that I can have the S on the positive side. So it's going here, so I can have just W and S on the positive side, and so it doesn't screw up the thing. And using an arithmetic logic gate is not necessary, you can use whatever, but using this arithmetic gate you can do something very nifty, which is have a multiplier to customize how much different sources affect the fuel. For example, here we have a constant of 1, so it's going to give an input of 1, so the scale is going to be basically 1. However, here we have a constant of 2, so it's going to give a multiplication, so 1 times 2, it's going to be 2, obviously, and it's going to give an output of 2 here, making the scale relative to 20. And if we go and do both at the same time, it's going to be basically just giving it an output of 3, which would equivalent to a scale of 30. This one over here is the refueling logic thing. It's basically the same, just constant of 3, but we make sure to give it a negative so that it just drains it instead of fills it up. And that's pretty much it. It's extremely simple to do fuel systems right now. But enough with the simple stuff, let's move on to the advanced fuel system. Alright, I have a lot more stuff over here, so let's get through with it. I have prepared 2 versions of a fuel system we can make. So to the left we have one and to the right we have one. We keep in mind you can obviously mix and match and do whatever you want with it. But let's start with the left one. If we head this way, basically what I'm gonna do is pretty much the same. Just gonna increase the thrust. We can see it spinning slowly, and yeah. But if we increase the thrust, it's gonna consume more fuel. This is a variable fuel consumption model. It's gonna consume more fuel the more thrust you give. So that is pretty nice to use with planes, and you might notice that I'm using a different type of system here. This is because I'm saving a gate, because I already have a constant output and it's just going to be a bit easier. Now right here on top, let's get rid of that and refuel our system, same as before. But right here we can see I have a separate little thingy, and this thing like here, it's very nice. It's basically just gonna give you an indication with the hue panels of how much fuel you have, and up top there is a blinking alarm light that is gonna trigger once we have used 80% of our fuel. So if we give it a try, we can see the colors changing, and once we go about 80 it's gonna start blinking. And yeah, that one is pretty nice to have as an immersion model, and it's quite nice. So let's refuel this thing and move to this other side. This one is more suited to cars, really, because what we're doing here is I have basically the same system as a variable input, but it's not holding the NOR gate up there. Whenever I release W, the NOR gate is reducing the accumulator, so it's not gonna stay like that. I would need to be managing how much I want by pressing. Don't mind the piston, it's just to stop the wheel. Now this one has something else, because you might have noticed I have been pressing W but nothing is happening, and that is because we have a lock. We need to first turn on the lock, and that's gonna be like idling your car, starting your engine. But what we can do here is that having a car start up and idling is still gonna consume fuel, so we can do that, and it's gonna be consuming a little bit of fuel. And if we start feathering this, it's just gonna increase how much fuel we're using. Just like that. We can turn it off, it's gonna stop, and we can refuel, obviously. This one is also quite simple actually, but let's move on to the build mode settings. Okay, first of all, we have this part is basically the same as before, it's just the refueling system going into the accumulators. Now, here I'm using a different way of turning off the stuff. It's going to do an AND gate, and this is important. It's advisable to use XOR gates instead of AND gates, but since we are not using the inputs directly in the AND gate, but we're giving it through the feathering accumulator, we can use the AND gate and save on a logic block. Because the way we're doing this, it's very important that you do this correctly, otherwise you're gonna have trouble. We're gonna have the constant output that we have. Well, you probably have one in your build already, they're quite useful, and you're just gonna give it into the AND gate. And then the comparison block, you're gonna set it backwards. We're gonna set it to not equals the maximum, and then we're gonna set it to -1. And that is gonna be doing basically the same. It's gonna stop giving an output, deactivating the AND gate whenever this fills up completely. The importance of this being -1 is because the constant output is +1. So -1 plus +1 is gonna be 0, and we want 0 because we want this value that's gonna be going outside of the accumulator here to pass unaffected through the AND gate. So it's very important that we keep it from 0 to 1, because that is the maximum an AND gate will be handling. And because, for example, if we just kept this with +1, it wouldn't matter if we had here like a 0.5 or a 1, it would add up. It would add up this 0.5 plus 1 plus 1, and it's gonna be bigger than 1, it's gonna clamp it down to 1, and so we lose the feathering ability. So yeah, this negative is very important. Now this AND gate is basically doing the same as the XOR gate, just going to the thrusters and number display just to show here what output is going out. Very easy to troubleshoot. If it's not working properly, connect stuff to number displays and you can see if it's giving the output you want or if it's not, and then if it's not, you know something is wrong. This is quite simple, it's just connected to the accumulator and the AND gate, nothing else. I already told you that you needed the maximum of 1, minimum of 0. You can change the scale to pretty much whatever you like. Yeah, then the accumulator here is gonna go to the comparison gate, and it's also gonna go into this fuel showing system. First it's gonna go into an arithmetics block. This is for the light panels, and then this comparison block is for the blinking light. We're gonna go through the comparison first because it's simpler. This is quite simple. We can set it to whatever we'd like. In this case we set it to duration 0.3 plus 0.3, a threshold of 80 and greater than, and what that's gonna do is gonna give a blinking output whenever this is over 80, but you can customize it to do pretty much whatever you like. Moving on to the hue part, we're gonna have to multiply this down, and this is very important. Right here it says 0.4, but it's not 0.4, it's just rounding it, but actually what is in here is 0.35. Even if it rounds it, keep in mind that it does work, it has registered the 0.35. That is going to go into another arithmetics block, and it seems like it's saying 0, but this one is saying negative 0.01. And that is important. Again, it's gonna round it, but keep in mind it does save it. We're using two arithmetics block because if we multiply 0.35 times negative 0.01, it would be negative 0.035. But essentially what's gonna happen is that the number is too small to put in a single block, so we need to do two. And that's gonna go into the displays here. That's gonna be controlling the color shift, and here we're gonna do a little shenanigan here. This one is set to addition. It's just so basically gonna be a constant output, and we want this at 0.36. That is gonna make it so it stays a nice bright green from the start, and then the other gates are gonna be reducing that amount up until 0.01, which is still red. We don't want it to go down to 0 because that would give us black, and well, basically it's gonna turn off, so we don't want that. We just want it to stay at red. But I can show if we set it to 0.35 and we just consume all the fuel, it's gonna go down, 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 all nice, but then when we go all the way at the bottom, it's gonna turn off. And well, if you want that, you can do it, but I prefer to have the red light indicating there's no fuel. Moving on to this side, we have here pretty much the same as before. There's the accumulator goes into the comparison into AND gate into this key right here. It's just to slow down the engine, but in practice you're gonna have that connected directly into the engine. This time we are not connecting the accumulator directly into the AND gate and the other accumulator. We're passing it first through a check to make it toggleable on and off. So same as before, we gotta be careful. We got output of +1 going here, and this time the input of -1 is going up here. So whenever we press 1, it's going to be enabling this AND gate to pass the signal from this accumulator. This NOR gate is set with a W, same as the accumulator here, and what this is going to do is basically whenever I press W, this NOR gate is going to turn off, and this accumulator is going to get turn on, it's going to get more input. And yeah, we can set it up and customize it whatever we like. Just keep in mind to have here a negative number so that when you release W, the value decreases and not just keeps going. In this case I have -0.5, and what that's gonna do is have different speeds when going up or going down. So it's gonna take, due to the scale, it's gonna take 1 second to go all the way up and 2 seconds to go all the way down. That's how it works. Now moving on to this part over here. This one is just to do the idling, because I didn't want these negative input, I had to transform it, so negative times negative is positive, and this can go here again. I would advise to have as little toggles as you can, because EMPs can mess things up really fast if you have multiple toggles working together. So yeah, that's the reason I have this negative here, to cancel that negative, and it's just gonna do basically 0.2, so it's not as fast filling, and that's gonna be the idling. You can also do a lot of pretty nice stuff. For example, you can hook the refueling to a distance sensor. So if we go ahead and just consume all the fuel, we can get around, and if we stand on top of it, we're gonna be refueling. And this is a nice thing you could do to, for example, have a gas station. That should be pretty much it for these fueling systems. Obviously you can make a lot more with them. It's extremely customizable. The accumulator is just incredible. Remember to set your scale correctly to adjust for time. For example, if we set it to 0.01, which would be the minimum scale, well, we could set it to say a scale of 0, but that wouldn't do anything. So 0.01, it's gonna still work. It's gonna affect the timing a lot. So if my quick maths are correct, basically if we give it an input of 1, this scale of 0.01 is gonna be doing this. We do 1 divided by 0.01, and that's gonna give us 100, so it's gonna take 100 seconds to reach a scale of 1, and we multiply that times 100, because we have a scale of 0 to 100, and that's gonna give us 10,000, and so it should take 10,000 seconds to fill up. So we divide out by 60, that would be about 166 minutes. So we're gonna do a test. We're gonna set the scale to 0.75. So we're gonna do 1 divided by 0.75, that we're gonna multiply that by 100, and we got 133 seconds. So we divide that by 60, we get about 2.2 minutes. So we're gonna test that out, see if my math was correct. Alrighty, so it is done, and the editing me is gonna check out if that makes sense. And with that, I'm probably gonna put a formula over here for you guys to find out how much your scale you need depending on your settings. And yeah, so with that, bye.